Run away.
Am I audible? শুনতে পাচ্ছ
Yes, sir.
সবাই?
Yes, sir.
Yes, sir.
Today we are going to discuss. We have get a knowledge about the mixing of solids. There are various types of solids, parameters, various types of mechanism of mixing of solids we are discussing in the previous classes, and different types of instrument we also see, and their working principle and their disadvantage and advantage we also discussed there. Now this section we get on focus on the mixing of liquids. So when we discuss about the mixing of solids, it is a very much complicated and very much huge uh, mechanized process when we are going to mixing of solids in pharmaceutical industry or in laboratory scales, because there are several parameters are there, several types of solids phase we are using there, and it's make more difficult during the mixing. And if any parameters is going to be changed, what happen? Your mixing process is not done uniformly. So in case of liquid mixing, it is easier than the solid mixing. But some complications also present in the mixing of liquids. But comparatively, according to solids, the liquid mixing is more easier than the solid mixing. So come on to the first slide of mixing of liquids. Here first point you see that the liquid mixing is considered to be as a simple operations compared to that of solid liquid mixing or solid mixing, whatever. Because when we are going to mixing of solid phase and liquid phase, here also two phases there, and when we going to mixing of two different liquid, there are also two phases there. In case of liquid mixing, the two phase are liquids, or in case of solid mixing, the two phase are liquids, or one phase solid, or one phase liquid. So in case of liquid mixing, if both liquids are compatible with each others, so they are not required to higher force in the mixing process. But in case of solid liquid mixing, we have to incorporate higher amount of force, higher amount of shear during the mixing process. So this is the difference between the liquid mixing and the solid or solid liquid mixing. So in the comparison, that liquid mixing consists lower amount of force in the mixing process. So as compared to the solid liquid mixing, it is much more lower shear force is applied in this mixing process. So it is easier process than the solid liquid mixing. After the mixing, we get a mixture. It is called the homogeneous mixture, and this system is called the homogeneous system. Why it is called homogeneous? Homogeneous and heterogeneous, two terms is there. Heterogeneous means single phase, and homogeneous means more than single phase or more than one phase. If your phase consists two or more or greater than two amount of phases, 3, 4, 5, anything, if they are mixed uniformly and get a mixture or get a system, it is called the homogeneous systems. So this homogeneous system we can get in case of solid liquid mixing and the liquid mixing, both phase. It gives the homogeneous system or homogeneous mixtures. So similar to solid mixing, fluid mixing also involve the application of the CI. As compared to the solid mixing, where higher amount of shear force we can include in the mixing process. So as well as depending on the solid mixing, in case of fluid mixing, we are also incorporate some amounts of shear forces, some amount of forces into the mixing process, depending on the what type of compound we are dealing with this mixing process. Okay, what type of liquid compound or liquid phase we are containing in this mixing process, depending on the mixing process, and depending on the what amount of liquid phase and what is the quality of the liquid phase present in this mixing process, depending on those parameter, we can conclude that what amount of shear forces we have to apply in this mixing process. So depending on the mixing process, we can conclude that there are two types of shear forces or two types of mixing mechanism we can conclude here. First one is the agitations and second one is the mixing. Agitation, it is the one of the part of the mixing process, because mixing have the several parameters. Several types of mixing is going on in the liquid mixing process or solid liquid mixing process. But in this mixing process, when in going for mixing process, first mixing is the random distribution or random mixing, where mixing is done with the random motions, where the shear force is applied, strong shear force is applied in this mixing process. So So that's why the mixing is going to be random in motions or random distributions happen. But in any mixing process, when we apply the slow shear forces, we have maintained a low shear forces or low forces in this mixing process, and this stirring capacity or the agitations capacity, it should be in a induced motions of a material and specified in one way. Means if you doing in a clockwise manner, so you have to go the all time clockwise manner until the mixing process is completed. If you are go to the anti-clockwise manner, you have to continue the anti-clockwise manner until the mixing process. But in between the mixing process, you do not change or you can't change the mixing way or mixing pattern. Okay, so this process is called the agitations. Agitation is a one part of mixing process where you have to maintain the mixing pattern, and the slow shear forces you have to apply in between the mixing process. Okay, if you apply the higher forces, what's happened, the agitation is converted to random distributions or random forces. So that's why this is called the random mixing. So first phase is the agitations, and second phase is the mixing distributions. So depending on the nature of liquids, we have divided the three main mixing liquids which is to be included in the mixing process. First one is the miscible liquids, second is the partially miscible liquids, and third one is the immiscible liquids. In case of miscible liquids, miscible in all proportions like ethanol and water, because ethanol water is fully miscible with each other. Each portions have to be miscible with each other. There are no immiscible phase or there are no partially miscible phase is not there. It is fully miscible with each other. It is called the miscible liquid. Partially miscible liquids means one part is miscible and another part is immiscible. So they are miscible with one another is a one part, and another part is proportion, another part or proportion is not miscible with each other. Okay, it is called the partially miscible liquids like paracresol and water. Paracresol and water, when is to be mixed, you saw that some amount of portions is already mixed, lower portion, but upper portion is given some immiscible criteria, immiscible texture, which is to be give the partially miscible liquids. And immiscible liquids means it is totally immiscible or not miscible with each other, like oil and water, vegetable oil and water. Oil and water, it is immiscible with each other. Okay, so these textures is to be depending on the mixing of the liquids. So now coming to the applications of liquid mixings. What type of application is important in case of pharmaceutical industry as well as in the normal laboratory practice? If you are mixing two types of liquids, or you are going to be mixing with a cold solutions, okay, and in between the mixing process, you have to be uh, you have to need to give the warmth to liquid for during mixing or get produced heat during the mixing. So in between the mixing process, first you have to generate some burner or heating process during the mixing, and another process is there. This is the directly induced or directly incorporated any hot liquid directly to the cold liquid. So when you incorporate the hot liquid directly to the cold liquids, what happens when both liquids are mixed with each other? It's give a homogeneous mixture, hot or warm homogeneous mixtures. So by this process, you can transfer the heat from one phase to another phase. So this is the first advantages of the liquid mixing. And by applying this mixing process, you can promote, you can transfer the heat from one phase to the another phase. And by this liquid mixing process, you can help to get more amount of crystallization of drugs during the drug synthesis or API synthesis. Okay. In future, when you are go for the chemistry lab drug synthesis, you see that after synthesis of any drugs, there one crystallization process is there. Crystallization means to remove the impurity from the crude drugs or drug substance. So how to remove? First, you take the drugs in a vessel and keep it on a ice, and normal stirring is going this. So during stirrings, a chemical reaction is happening between the impurity and drug substance, and by this process you can get the higher yield of substances. Your yield percentage, your API substance or your crude drug substance is yield is increases. You have get to 90 to 100% amount of yield. Okay, and your impurity profile or impurity substance is also removed by this process after getting the filtrations. Okay, so by this liquid mixing process, we can get the maximum amount of yield or maximum amount of drug substance during the synthesis. And another important, most important process of liquid mixing is to design the drug substances or manufacture some doses from in pharmaceutical industries. Different types of liquid doses form are there. You know already about that. That suspensions, emulsion, solutions, aerosols. So both are prepared depending on the liquid mixing parameters. Okay. So suspensions and emulsions both are biphasic doses form because they are consist the two phase. In first phase is the dispersion phase, and another phase is the external phase. Dispersion phase means which phase is dispersed or incorporated in the another phase. This another phase is called the external phase. Okay. So depending on these phases, we can use the liquid mixing process in this criteria or in this dosage form design. So in case of suspensions, we know that suspensions include some amount of solid with liquid. So when solid and liquid is mixing in a uniform manner, we get the suspensions. So this solid and liquid mixing is done by the liquid mixing process. Example, calamine lotions. It is one of the suspensions. And same type, the emulsion, it is also biphasic dosage form. Okay, and this is a liquid-liquid mixing process, but both liquids are immiscible with each other, and these immiscible liquids are miscible with the help of an emulsifying agents. We can get the emulsions. Like benzyl benzoate emulsions is prepared by the liquid mixing process. Solutions. Okay, any types of solutions, sugar solutions. Okay, so like here there B complex elixir is prepared by the liquid mixing process by addition of the solution liquid and liquid, or by addition of the solid and liquid. But the solid, it should be soluble in nature. Next is the aerosols. Aerosols in future you have to get rid in pharmaceutical dosage form. Aerosol is a one type of spraying systems like body spray. Okay, and this system is consist liquid and gas. Gas help to propagate or expel out the liquid forms from the containers, like salbutamol inhaler. You all about know about the inhalers or the inhaling systems. What happen when you press the button? Some amount of liquids is come out or expelled out from the containers. These expellations is done by the using gas. There are several types of organic gases in use in these containers, which compress the liquid. Okay, and when gas pressurize the liquid, it's become converted to small droplet. So when we release the pressures, the gas is expelled out. When the gas is expelled out, it's come the droplet of liquid in come outside. So that's why when we using the body spray is a one types of aerosol system which can consist some amount of gases and some amount of alcohol. Gases help to separate the alcohol and come out in the containers, and which will use as a, and when the alcohol is come out the outside, it also consists the perfume in outside. So that's why we get the smell from the body spray containers. So this total process, gas and liquid mixing, is also done by the liquid mixing process. Okay. So these are some of the popular dosage form we can get manufactured by the mixing applications or liquid mixing process. Now coming the mechanisms. What type of mechanism we are using in this mixing process? There are four types of mechanism we are using in the mechanism of liquid mixing. First one is the bulk transport. Bulk transport means movement of large portion of material from one location to another locations. Okay. When going to liquid and solid mixing, what happened? The large amount of solids due to the presence of liquids, it transfer from one phase to another phase. Here bulk means the solid portions. Okay. If we replace the solid with the immiscible liquids, okay, when we get mixed, what happened? The one portion of immiscible liquids, it transforms from one large portion to the small one locations. Okay, this is happened according to the ascending order. Okay, large portion is come to depending on the concentration, it's fulfill the criteria of the less concentration of the portions. Large concentration come into the less concentrations, it is called the bulk transport. Okay, it is happening during the solid liquid mixing or the liquid mixing. Okay, so these types of mixing is done by some using blades and paddles. Okay. Next is the turbulent mixers. So in the previous sections of the solid mixing, we can conclude that when mixing is going on, some particles are going to zigzag motions or three-dimensional movements. So when three-dimensional movements is going on, the mixing process is going to uniformly. We know that. So according to solid mixing as well as liquid mixing also consists these types of zigzag manners or these types of three-dimensional mixing process. It is called the turbulent mixes. Turbulent means the ununiform flow of liquids. Okay. This ununiform flow is created by some amount of device which causes the mixing due to turbulent flowing natures, which result in a random fluctuations of the fluid velocity. Means one time fluid velocity is increases, one time decreases. Is a large fluctuations is get involved in the fluid velocity at any given point within the systems. So fluid velocity at a given point is changes in a three directions, x, y, z. Okay, it going to the any direction. It is called the three-dimensional mixing, and this three-dimensional mixing is called the turbulent mixing. Next is the laminar mixing. Laminar means unidirectional flow maintained in between the mixing process until the mixing is completed. Okay. Means two dissimilar liquids we have to get in the mixing process, and through you maintain the laminar flow, means unidirectional flow, which is not consist any types of turbulent mixing or any types of random fluctuation. It is continuously maintain the same velocity until the mixing is completed. And you have to maintain the shear forces or shear stretches in between the mixing process, which has to be uniform in natures. Last is the most important is the molecular diffusion mixings. Molecular diffusion is only happen when you mixing the liquid mixing or solid liquid mixing. What happens during this mixing process? The particles are diffused with each other. Which types of particles? Like solid particle consist. Solid type particles diffused by the liquid particles. Liquid particle incorporated into the solid particles. What happens? The solid particles get dissolved. Okay. When the liquid particles are incorporated or diffuse, diffuse means incorporated with each other. When diffused in the particles of solids, the solid particles, due to the diffusions of the liquid, it become dissolved. Okay. So this is happen, and this is increased by the thermal motion. When I have to get increase the heat portions during the mixing, and due to increases the heat, diffusion process is increased. So molecular diffusion is increases with the temperatures. These are the four important mechanisms of liquid mixing. Now come get idea into the mixing vessels. So all mixing vessels are similar like this, and what is the changes in between happen in the mixing vessel depending on the mixing, the vessel size is increases or size is decreases, and this mixing device is changed during the depending on the mixing process. Overall, this process is same. This tank is prepared by or made by a stainless steel. Okay. So in case of industrial grade stainless steel, 316 grade is used for preparing or made this tank. Okay. And this mixing device consists a impeller. Okay, impeller means mixing blade, which give to help in this mixing process. It is called the impellers, and several types of impellers is present in pharmaceutical industries. And it is mounted by a shaft. Shaft means where the impeller is attached with a motor, and motor is connected with a shaft. Shaft means a rotating device. Shaft is revolving or moving in process. Okay, and shaft is attached with this impellers, and shaft is attached with this impeller and the attached with the motor device. Okay, motor or drive, and this shaft is driven by the motors. Tank is size is depending on the what type of material we have to mixing with each other in this process. So depending on the mixing process, we can increases or decreases the tank size. And this tank is consist a inlet process and outlet process. Inlet where you have incorporated both liquid in between the tank, and outlet means you get the mixture from the outlet process. The tanks also consist a separate portion of buffles. Okay, you have removed the buffles or add the buffles in this process depending on the mixtures, what type of mixture we have to get mixed. Buffers means is the extra mixing device except impellers. Impellers is also helping in the mixing process, but buffers is also give the attrition process during the mixing. What happen when impeller going to mix? The mixing during mixing process, the solid particles or liquid particles are get deserted or attracted by the buffles. Okay, and the buffles give a trace between the stress forces between the two phases, and due to presence of stress, the mixing process is going quick. Okay, and buffles induce the mixing process during the mixing. The weight of the buffles is maybe from 1 by 10 to 1 by 18 of the tank diameters. What type of tank you are using, what is the diameter of the tank? Depending on the diameter, we can conclude that the weight of the buffles is 1/10 to 1/18 of the tank diameters. Okay, so this is the normal diagrams of the mixing vessels which is using in this mixing process. Now come into the mixing device. One mixing device you have to know, it is called an impeller. And impeller is a mixing device name, but impeller is divided in three more parts. Okay, three more devices. Depending on the structures, depending on the mechanism, and depending on the use, the impellers are divided into three types: propellers, turbines, and paddles. So one by one, we know about that. First is coming to propellers. You know, so that the propellers is look like a table fan blade. It is look like a fan blade. But here several propellers is there. Some propellers are three blades, some propellers are two blades, and some propellers are more than three blades. So this has to be used depending on the what type of mixture or what types of mixing process we have to involve. So basically, standards propellers consist three blades in nature. So three blade design propeller is most popular in the mixing industry. The blades may be prepared by stainless steel, and it is have a right or left-handed depending upon the slant of their blades. Two or more propellers are used in the mixing deep tanks. Okay, size of the propellers is small and may be increased up to zero point 0.5 meters depending on the size of the tank. Depending on the size of the tank and depending on the sample quantity, we can increases the propeller speed and propeller size. Propeller size is some amount of standard depending on the 0.5 meters increase. If your uh, standard size is something 10 meters, okay, but your tank diameter is increases, so you have to increases the 0.5 meters depending on the size of the tank. Small size propeller can rotate up to 8000 rpm, means small size propeller it can rotate in slow speed to high speed also. Okay, it can rotate 100 rpm, it can rotate 500 rpm, it can rotate 300 rpm, it can rotate 500 rpm, up to 8000 rpm it can rotate. Okay, and produce the longitudinal movements. And it is the advantage of the propellers that it is not from any types of vortex. Vortex means it is a centrifugal force. When you stir a liquid by a glass rod in a glass beaker, and after going to start, it increases the stirring rates. What happened? You see that the some amount of cone shaped force or cone shaped velocity is produced in between the liquids. Okay, it is called the vortex. And if your mixing process is create any vortex mixture or vortex shaped velocity, what happen? Only in the middle phase you have to go for you have to mixed. Okay, but the side by side phases it is not included or not maintained during the mixing process. So it is the advantage of the vortex mixing process, but propellers are not producing or not creating any types of vortex mixing or vortex mixtures in the mixing process. Okay, it is only maintain the longitudinal movement. Now coming to the advantages of the propellers. What types of advantages? It is useful for high mixing capacity easily in case of mixing. When you are preparing the high amount of mixtures for high mixing capacity, you have to use the propellers in this mixing process. Effective for liquid which have maximum viscosity 2 pascals. If you are dealing with some viscous liquids like glycerin, okay, so these types of liquids have the viscosity 2 pascals. Okay, so and you have to go for mixing a slurry or you have to produce a slurry by these types of viscous liquids, so you can incorporate the propellants in this mixing process. And it is also handle the slurry portions, which slurry consists 10% of solids of the main starch. If any slurry consists 10% of solids, you have to mix by the propeller mixtures. And it is effective also in case of gas liquid dispersions. It's possible at laboratory scale. Gas liquid dispersion is happening in case of aerosol dosage forms. When you're going for the preparations of production of the aerosol preparations, the gas and liquid dispersion is technique is used, and this gas and liquid dispersion is done by the propellants. Disadvantage. What are the disadvantage of the propellants? Propellers are not normally effective with the liquids or viscosity is greater than 5 pascal. It have to maintain the mixing process when viscosity is 2 pascals, but when it is increased up to 5 pascal, it is not maintained by the propellers. Okay, so this is the demerits of the propellers. Otherwise, propellers is a good mixing device in pharmaceutical industries. Now coming to the turbines. Why it is called turbines? Because it is consists two types of blades. First is the disc shaped blades you showing in the pictures. That first is the disc. One another is disc is there, sharp disc, and this disc, circular disc, is connected with a small portions of the blades, and some of the blades are bent and some of the blades are straight forwards. Okay. So turbine consists of the circular discs to which a number of short blades are attached, and blades are maybe straight or curved with each other. In case of diameters, depending on the vessels, maximum 30 to 50% ranges of turbines is used in mixing industry. Turbines can rotate in a lower speeds than the propellers, 50 to 200 rpm. But its mixing process is more efficient than the propellers. Okay. Flat blade turbines produce radial and tangential flow. As the speed increases, the radial flow is dominates. Radial means and tangential flows. The turbines create two types of flow. First one is the radial and next one is the tangentials. Radial means ki, radial means it is rotate depending on the axis or radius. When it is moved according depending on their axis, and involvement of this axis is can rotate radially. Okay, it is called, and it's create a force, it's a flow, it is called the radial flow. But it's sad, it sometimes is changes its positions. Okay. So that it's create a angle flow, it is called the tangential flow. Tangential means angle flow, radial means axis flow. When it's going to the axis flow, it is called the radial flow, and when it going to be the create a angle flow, it is called the tangential flow. Okay. Tangential flow is happen when the shaft portions of this blade is some become uh, curved in nature. So that times tangential flow is increases. But when this mixing process is increases, or speed increases, that time what happened? The tangential flow is not used. The radial flow is dominates. So pitch blade turbine produces the axis flow. So near the impeller zone of the rapid currents, high turbulence and intense shear is observed. The shear produced by the turbines can be further enhanced using a diffuser ring, means stationary perforated ring which to be surrounded in the turbine. If any types of pore present in the turbine blade, what happens? The shear, when they produce the shear force or producing any types of force during the mixing process, it become enhanced and using the diffusing ring, and the shear force is increases due to the presence of pore or perforation is present in this process. So diffusion ring is increases and shear forces, and the liquid passes to the perforations, reducing the rotational swelling and vortex. Okay. If your blades it consist any types of perforations, so what happen? If vortex is forming but any types of extra force is created during the mixing process, the maximum amount of force by extra force is can remove by the perforated area of the blades. So what happened? It, by these perforations we can reduce the swirling and the vortexing of the mixing process. Now come into the advantages. Turbines give the greater shearing forces than the propellers, to the pumping rate is less. In case of propellers, if your speed is not increases during the mixing, we can use some pumping device to applying the extra shear force. Okay. But in case of turbines, it consists a circular blade attached with a perforated or non-perforated some blades. So these blades help to increases the radial flow, and which need not to any types of pumping device during the creation of the shear forces. So that's why it is most useful device in case of emulsion preparations or emulsification process. Effective for high viscous solutions with a wide range of viscosity like 7 Pascal per second. Okay, which can be create the high viscous liquid. It is useful for high viscous liquids. In low viscous material, of large volume turbine create a strong currents which spread throughout the tank and destroying the stagnant pockets. Okay, so in case of low viscous material, if it consists large volumes, so in case of low viscous material, what happen? Some types of droplets they are formed in between the mixing process. Okay, so these types of droplets is can be destroyed. It is called the stagnant pockets. It should be destroyed during the mixing process by the turbines. They can handle slurries of with 60% of solids. 60% of solid it can handle by the turbine process. And in case of propellers, they have maintained the 10% of solids, and turbines maintain the 60% of solids during the manufacture of suspensions or other dosage form. Turbines are suitable for liquid of large volume and the high viscosity if the tank is buffeted. Okay. So turbines are suitable for liquids and large volume and high viscosity material, and if the tank is buffeted. Baffle is using in this turbine process. You can get or more uniform mixtures from this mixing process. Now it is the last part of the impeller. It is called the paddles. Everybody you know about the dissolution process with apparatus, and dissolution apparatus is consists of one type of paddles. Okay. The top paddle it is using in case of dissolution purpose, and other paddles are using in case of mixing purpose. So the paddle functions is various paddles is using in the mixing industry, and in case of quality assurance or quality control portions of the industries. Paddle consists of a central hub with long flat blades attached to it vertically with a portion of shaft. It is also connected with the shaft. Two blades or four blades are common in the mere paddles mixing process. Sometimes the blades are pitched and may be disc or hemispherical in shape. It is zip-shaped, piece-shaped, or the hemispherical in natures. Okay, and is attached by the shaft, and shaft is attached with a motor driven. The paddles rotates in low speeds only, and paddles maintain the agitation speeds. Okay, paddle is not using in case of high force mixing process. It is basically used in case of low speed mixing process, and it's basically giving the agitations mechanism of mixing. And up to 100 rpm it can speed rotates. They pose the liquid radially and tangentially with almost no axial actions unless the blades are pitched. In deep tanks, several paddles are attached, one above and other on the same shaft. Okay. If your tank is more large and deep tank, so there you use the several paddles for mixing purpose, and use the several shafts, and shafts are connected with the paddles. Every load speeds it gives the mild agitations in unbaffled tanks, but in case of high speed mixing, baffles are necessary. If you try to use this paddle for high speed mixing, so you can using the baffle in the mixing tank, because baffle is induces the mixing process. Now, what is the use? Paddles are used of antacid, agar and pectin related purgatives, and the antidiarrheal mixtures such as bismuth kaolin. These types of normal preparation or normal dosage form, which requires the small amount of forces or shear forces, this has to be handled by the paddle device. Advantages: vortex formation is not possible with the paddle impeller because it is maintaining the low speeds or the poor speed mixing, because the vortex only formed during the high speed mixing. Disadvantage: mixing of the suspension is poor, therefore buffle tanks are required. Because suspension is consist some amount of solids, it is 10%, 20% or 60%. Okay, if it is 60%, it is not done by the paddles. If it is 10% or less than 10%, you have to use the paddle, but remember that you have to incorporate some buffers in the mixing tanks. So by use this mixing device in paddles and by use these buffers, we can get more uniform suspensions by the mixing process. So these are the three main parts of the mixing process: propellers, turbines, and the paddles. These are the main mixing devices. So today class up to this. In next class, we have to discuss about the main mechanism of the vortex and the what types of uh, equipment or what type of machines, mixing apparatus used in this liquid mixing process in pharmaceutical industries. So any questions regarding this class?
স্যার বাফেল ট্যাঙ্কটা একবার একটু বলবেন স্যার?
বাফেলস একটা এক্সট্রা পোর্শনস অফ ট্যাঙ্ক। ওকে, এই ডায়াগ্রামটা ভালো করে দেখো। ডায়াগ্রামটা কি আছে? একটা ব্লেড দেখতে পাচ্ছ তলায়, ইম্পেলার যেখানে লেখা রয়েছে, ঠিক আছে? ব্লেডটা কার সাথে অ্যাটাচ আছে? একটা শ্যাফট, তার সাথে একটা মোটর। এটা হচ্ছে ব্লেডের ফাংশনস। ব্লেড মিক্সিং করছে ইউনিফর্ম, আর এই পার্টসে দুটো আলাদা আলাদা পোর্শন দেওয়া হয়েছে, স্কোয়ার সেট, লেখা হয়েছে বাফেল। বাফেলস হচ্ছে যে যখন কোনো মিক্সিং বাফেলস তোমরা বেসিক্যালি দেখতে পাবে হচ্ছে এক্সাম্পল দেয়া, এক্সাম্পল এখন ঠিক আমার মাথায় আসছে না। ছোট যখন মিক্সিং কোনো পোর্শন বা মিক্সিং কোনো ডিভাইস দেখবে বা কোনো মিক্সিং কাপ, তার মধ্যে দেখবে যে সাইডে সাইডে কিছু কিছু পোর্শনস তোমার উঁচু উঁচু হয়ে থাকে গায়ে, তোমার ট্যাঙ্কের গায়ে অথবা কোনো কাপের গায়ে কিছু পোর্শনস মাউন্টেড থাকে, যেটা একটু বেরিয়ে থাকে ট্যাঙ্ক থেকে গায়ে, আর কাপ থেকে গায়ে সেটা বেরিয়ে থাকে। যে পোর্শনটা বেরিয়ে থাকে সেই পোর্শনটাকে তোমরা বাফেল ধরে নিতে পারো। কি হচ্ছে, যখন ইউনিফর্ম সেক করছো কোনো মিক্সচারকে, ঠিক আছে, ডিউরিং সেকিং হোয়াট হ্যাপেন, যে সমস্ত তোমার লার্জ পার্টিকেল বা কিছু আনমিক্সড মেটেরিয়াল রয়ে যাচ্ছে, সেগুলো বাফেলসের গায়ে অ্যাট্রিশন ক্রিয়েট করছে বা ধাক্কা খাচ্ছে। ধাক্কা খাওয়া দরুন প্রত্যেকটা মেটেরিয়ালস ব্রেক হয়ে যাচ্ছে নিজের মতো, বা ড্রপলেট গুলো রাপচার হয়ে যাচ্ছে, বা কোনো ড্রপলেট যদি ইমিসিবল থাকে সেটা মিসিবল হয়ে যাচ্ছে ডিউ টু দ্য প্রেজেন্স অফ বাফেলস। বাফেলস আর কিছুই নয়, জাস্ট একটা স্ট্যাগনেন্ট ফেজ। স্ট্যাগনেন্ট ফেজটা ডিউরিং মিক্সিং একটা এক্সট্রা ফোর্স ক্রিয়েট করছে during the mixing process. So what happened, due to the presence of the extra force, your mixing process is induced. Okay, so side by side impeller produces a force and buffels also produces a uniform force. So two mixing force, you give a uniform mixtures after the mixing process.
ওকে স্যার, ওকে ওকে।
আর কোনো কোশ্চেন্স?
স্যার স্যার ওই যে মেথড চারটে ছিল না, ওই লাস্টের মেথডটা একবার বলবেন?
লাস্টের মেথডটা হচ্ছে মলিকিউলার ডিফিউশনস। তোমরা সলিড মিক্সিং এ পড়েছো যে যখন সলিড সলিড একটার সাথে একটা ইনকর্পোরেট হয়ে যায়, তখন সেটাকে কি বলে? একটা সলিড যদি একটা সলিডের সাথে অ্যাটাচড হয়ে যায়, কি বলে সেটাকে?
অ্যাডহেশন।
কি বলে? বলো বলো বলো, কি বলে সেটাকে? সেগ্রিগেশন বলে না? সেগ্রিগেট ফর্ম করে তো, যখন একটা পার্টিকেলস একটা পার্টিকেলের সাথে অ্যাটাচ হয়ে যাচ্ছে।
সেগ্রিগেট ফর্ম।
পড়াশোনা করছো না, বোঝা যাচ্ছে। যাই হোক, ইন কেস অফ লিকুইড মিক্সিং এর ক্ষেত্রে লিকুইড সলিড মিক্সিং এর ক্ষেত্রে সেগ্রিগেট হতে পারে না, কারণ এখানে দুটো পার্টিকেলসই সলিড নয়। একটা পার্টিকেল সলিড হতে পারে, একটা পার্টিকেল লিকুইড হতে পারে, অথবা দুটোই লিকুইড হতে পারে, ঠিক আছে? এখানে কি হচ্ছে, যখন মিক্সিং করছে তখন লিকুইডের পার্টিকেল বা লিকুইড ড্রপলেটটা একটা সলিড পার্টিকেলসের গায়ে এসে পড়ছে। তো গায়ে এসে পড়ার জন্য কি হচ্ছে, সেটা কি হচ্ছে, সেগ্রিগেট হচ্ছে না, ডিফিউশন হচ্ছে। ডিফিউশন মিন্স ওই লিকুইডটা আস্তে 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 সলিডের মধ্যে ইনকর্পোরেট করছে। যেই সলিডের মধ্যে ইনকর্পোরেট করলো, কি হবে, সলিডটা আস্তে আস্তে ওয়েট হয়ে যাবে, ভিজে হয়ে যাবে। আস্তে 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 সলিডটা ডিজলভ করতে শুরু করবে। তো বাই দিস প্রসেস এটাকে বলছে মলিকুলার ডিফিউশন, মিন্স একটা মলিকুলের মধ্যে ডিফিউজ হচ্ছে, আফটার ডিফিউশন গেটিং ডিজলভ ইন দিস মিক্সচার। এবং যখনই মেটেরিয়ালটা ডিজলভ হবে তখনই তোমার মেটেরিয়ালসটা কি হবে, নয় সলিউশন হবে, আর যদি ডিজলভ না হয় তাহলে সেটা সাসপেনশন হবে। ওকে, তো ইন দিস প্রসেস দ্য মেইন মেকানিজম হচ্ছে মলিকুলার ডিফিউশন, মিন্স একটা পার্টিকেলের মধ্যে ডিফিউজড হচ্ছে। একটা ট্যাবলেটকে যদি তুমি জলের মধ্যে ফেলে দাও কি হবে, ট্যাবলেটটা আস্তে আস্তে গলে যাবে। কেন বলবে? কারণ ট্যাবলেটের মধ্যে আস্তে আস্তে ওয়াটারটা ইনকর্পোরেট হচ্ছে, ওয়াটারটা ডিফিউজ হচ্ছে। এই কারণে ফার্স্ট প্রথমে ট্যাবলেটটা সোয়েল করবে, তারপর আস্তে 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 ডিজলভ হয়ে যাবে তোমার ওয়াটারের মধ্যে। তুমি যেটা গ্লাস ওয়াটার দিয়ে নিয়ে নাও, your tablet is become dissolved or suspended in the liquids. It is called the molecular diffusion. আর কোনো কোশ্চেনস?
হ্যালো স্যার, স্যার বাল্ক ট্রান্সপোর্টটা আরেকবার বলবেন?
বাল্ক ট্রান্সপোর্ট হচ্ছে যদি তুমি নর্মাল ভাবে বুঝতে চাও, সেটা হচ্ছে একটা জায়গা থেকে একটা মেটেরিয়ালকে আর একটা অন্য জায়গায় নিয়ে যাওয়া। আগের দিন রোটেটিং সিলিন্ডার বলেছিলাম, রোটেটিং সিলিন্ডারও বাল্ক ট্রান্সপোর্ট হতো। কি হতো, একটা পোর্শন থেকে সলিডকে অন্য একটা পোর্শনে বাই রিবন ব্লেন্ডার বা রোটেটিং ব্লেডের মাধ্যমে সেটাকে ট্রান্সফার করছিল। এটা একটা বাল্ক ট্রান্সপোর্ট। ইন কেস অফ লিকুইড কি হয়, লিকুইড মিক্সিং এ যখন কোনো সলিডকে মিক্সিং করছো বা লিকুইড মিক্সিং করছো, সেখানেও একই পোর্শন হয়, যেখানে হায়ার কনসেন্ট্রেশন আর যেখানে লোয়ার কনসেন্ট্রেশন। হায়ার কনসেন্ট্রেশন থেকে লোয়ার কনসেন্ট্রেশনে মেটেরিয়াল ট্রান্সফার হচ্ছে, এটা কি বলছে বাল্ক ট্রান্সপোর্ট। কনসেন্ট্রেশন যখন সিমিলার হয়ে যাবে তখন তোমার ট্রান্সপোর্টটা বন্ধ হয়ে যাবে।
আচ্ছা
স্যার ল্যামিনার মিক্সিংটা কি বলবেন?
ল্যামিনার মিক্সিং মিন্স হচ্ছে টোটাল মিক্সিং প্রসেস যখন ইউনিফর্ম মিক্সিং তুমি মেনটেন করছো। ধরো তোমার মিক্সিং স্পিড তুমি 30 আরপিএম করেছো, আরপিএম এর ফুল ফর্ম কি?
ওই র্যাপিড, ওই কি আরপিএম তো, র্যাপিড ফেজ না, সরি,
রিভলিউশন পার মিনিট।
কারেক্ট, রিভলিউশন পার মিনিট। তো যখন তুমি কোনো মিক্সিং প্রসেসে 30 আরপিএম তুমি মেনটেন করছো, একদম তোমার মিক্সিং প্রসেস যখন স্টার্ট হয়েছে একদম শেষ পর্যন্ত তুমি 30 আরপিএম মেনটেন করছো। ডিউরিং মিক্সিং তুমি মিক্সিংটাকে রেখেছো একদম একই ম্যানারে। ধরো একটা বিকার নিয়েছো, বিকারের মধ্যে জল নিয়েছো, জলের মধ্যে চকের গুঁড়ো নিয়েছো, গ্লাস রড দিয়ে তুমি স্টার করছো। ইট ইজ ওয়ান টাইপ অফ মিক্সিং। ডিউরিং স্টারিং কি করছো, তুমি একই ম্যানারে স্টার করে যাচ্ছ একদম মিক্সিং শেষ পর্যন্ত একই আরপিএম। কি হচ্ছে তখন, কোনো টার্বুলেন্ট ফ্লো, টার্বুলেন্ট মিন্স কি, ফ্লাকচুয়েশন ইন ভেলোসিটি। তোমার ভেলোসিটিতে কোনো ফ্লাকচুয়েশন হচ্ছে না, তোমার তার মধ্যে কোনো মিক্সিং প্রসেসে কোনো ভর্টেক্স ফর্মেশন হচ্ছে না, ঠিক আছে। এবার তুমি ওই মিক্সিংটাকে যখনই আস্তে আস্তে স্টার্টিং করতে করতে হট করে জোরে মিক্সিং করতে শুরু করবে, কি হবে, তোমার মিক্সিং ভেলোসিটিটা চেঞ্জ হয়ে গেল। তখন কি হলো, তোমার ফ্লো ছিল ল্যামিনার, ট্রান্সফার হয়ে গেল কিসে, টার্বুলেন্ট। তাহলে ফার্স্ট ফেজটা কি ছিল, ল্যামিনার ফ্লো মানে ইউনিফর্ম ডিরেকশনস। তারপরে তুমি জোরে মিক্সিং করতে শুরু করলে তোমার মিক্সিং প্যাটার্নটা চেঞ্জ হয়ে গেল, তখন সেটা হয়ে গেল টার্বুলেন্ট ফ্লো। ওকে, তখন তোমার লিকুইড পার্টিকেল গুলো কোন দিকে মুভমেন্ট করবে, এক্স ওয়াই জেড, মিন্স 3 ডাইমেনশন। আর একটা কথা তোমাদের বলে রাখি, তোমাদের মধ্যে কিছু জন রয়েছে যারা ক্লাস অ্যাটেন্ড করছে না, কিন্তু আমি যখন ফিডব্যাক ফর্ম বা অ্যাটেন্ডেন্স ফর্ম রেসপন্স দেখছি সেখানে কিন্তু অনেক বেশি স্টুডেন্ট রয়েছে, ঠিক আছে। তো যারা ক্লাস অ্যাটেন্ড করছে না বা কিন্তু অ্যাটেন্ডেন্স ফর্ম ফিল আপ করছে, তারা কিন্তু অ্যাটেন্ডেন্স পাবে না, ঠিক আছে। আর আজকে থেকে কোনো গুগল ক্লাসরুমেতে কোনো অ্যাটেন্ডেন্স লিঙ্ক আমি শেয়ার করবো না, আমি চ্যাট বক্সেই অ্যাটেন্ডেন্স লিঙ্ক দেবো এবং এখান থেকে দেখে নিতে হবে। অ্যাটেন্ডেন্স লিঙ্ক আমি দিয়ে দিয়েছি চ্যাট বক্সে, তোমরা নিয়ে নাও, ফিল আপ করে দাও। যারা ক্লাস করছেন বা ক্লাসের মধ্যেখানে বেরিয়ে যাচ্ছে তারা কিন্তু অ্যাটেন্ডেন্স পাবে না।
স্যার মাঝে মাঝে ডিস্টার্ব হলে বেরিয়ে মানে বের করে দেয় অটোমেটিক।
হ্যাঁ, তখন
আজকে
তুমি
যেরকম
যখন আবার নেক্সট টাইম জয়েন করবে তখন চ্যাট বক্সে লিখে দেবে, ঠিক আছে, যে এনি কাইন্ড অফ ডিস্টারবেন্সেস দিস সিস্টেম ইজ রিমুভ মি আফটার এগেন আই এম জয়েন হিয়ার বলে তুমি একটা মেসেজ করে দেবে।
আচ্ছা স্যার, আজকে আমারও এরকম হয়েছিল।
স্যার এরকম একবার হলো স্যার, আমার নিজের থেকে বেরিয়ে আবার ঢুকেছিলাম মাঝখানে।
সেটা হতে পারে নেটওয়ার্কের ডিস্টারবেন্স, কিন্তু এখানে যেমন লাস্ট পার্টিসিপেন্ট হচ্ছে 65, ঠিক আছে, এই 65 জনই কিন্তু অ্যাটেন্ডেন্সটা পাবে। আমি যখন অ্যাটেন্ডেন্স পাচ্ছি তখন সেখানে আমি 80% বা 90% দেখতে পাচ্ছি।
ওকে স্যার।
আর আশা করবো তোমরা এটা নিজেদের মধ্যে কনফিডেন্সিয়াল রাখবে, যারা এই ফিডব্যাক লিঙ্কটা পাচ্ছ। যারা ক্লাস করছে না তাদেরকে শেয়ার করার কোনো দরকার নেই। তোমরা অ্যাটেন্ডেন্স লিঙ্ক নিয়ে নিয়েছো?
ইয়েস স্যার।
ঠিক আছে, তাহলে আমি এন্ড করছি এখানে।